When it comes to manufacturing electric vehicles, Tesla is in a unique position in the industry. As the most vertically integrated company in the automaking world, Tesla has the ability to attack any piece or component of its vehicle or the manufacturing process to make it better and more cost-effective. This is what Tesla has done with the new revolutionary tabless batteries it is going to be using in its future electric vehicles. Tesla announced a new tabless battery on its Battery Day event last year to critical acclaim. It was not just an academic exercise for Tesla, as it was born out of a specific need. Like other battery makers, Tesla has been purchasing its battery cells from suppliers that use their own proprietary chemistry and structure. This was working well until Tesla looked into the future and discovered that its battery supply chain could cause a problem. Tesla's target is to sustain a 50% year-on-year growth in total vehicle output. For instance, last year, Tesla shipped nearly 500,000 electric cars and set a target of 750,000 for 2021. All these cars will only be shipped if they have a battery in each of them. The problem was that according to its forecast, the growth rate in the current production of batteries would not be able to match Tesla's growth ambitions, creating a bottleneck down the road. Simply put, a time would come when Tesla would finish making its vehicles but need to wait for batteries to be finished up before installing them. The culprit here is the manufacturing process of the batteries, and we shall see more on that later. That is a scenario Tesla wants to avoid at all costs. As a result, Tesla set to work on the core components of batteries as we know them, and came out with the tabless 4680 battery. While the battery is a complex concept best left to the experts, it is possible to have a general idea of what Tesla has done here. The common cylindrical lithium-ion battery uses cells made of several layers or strips of chemical compounds to store energy. The layers are the cathode and anodes with a separator layer in between them. The cathode layer and anode layer then connect to the positive and negative terminals of the battery using small metallic components known as tabs. The problem with tabs is that they could be the downfall of the whole battery, despite performing a crucial function. They can affect the battery performance and reliability if not done right. For instance, when the tabs are welded onto the electrodes, they could be resulting welding burrs that can pierce the layer between the cathode and anode layers, causing an internal short circuit. This has the potential of causing a fire. Also, the step of inserting the separating layer between the cathode and anode layers introduces a time-consuming procedure during the battery manufacturing process. What Tesla managed to do is to eliminate the need for the connecting tabs, hence the name tabless battery. Instead, the battery uses a conductive portion that runs along the electrode. Using this method, there is less distance for the electron to travel before reaching the positive and negative terminals. This is a win for physics, as explained by Elon Musk, the CEO. The biggest deal is that Tesla has used a radically different approach in battery design. It is basically what Tesla is known for anyway, taking problems apart to be able to come up with the most fundamental solutions. With this first principles approach, Tesla managed to change both the battery and the battery manufacturing process, making each of them better, i.e., both of them ended up being optimized. Well, it involved acquiring a few battery-focused companies, but hey, Tesla pulled it off at the end of the day. In effect, in one fell swoop, Tesla improved the efficiency and capacity of its battery, reduced the cost of production and the time taken for production. And if you think this is nothing more than a concept and will take time before actual batteries can be made, you can't be more wrong. Tesla's Drew Bagliano reported that they were already ramping up the production of the tabless cells in their pilot plant. Here is how the tabless design makes batteries better. With the tabless structure, as noted earlier, a time-consuming step has been eliminated in the production of the battery. That is the step of inserting the tab itself inside the battery. This simply means more battery in less time. Remember, Tesla foresees a shortage of battery supply as its own vehicle production increases and battery component suppliers can't keep up with the pace. Here is Tesla forestalling such a scenario. It also means batteries with larger capacities. The 4680 appellation added to the battery name means the cells are massive at 48 millimeters in diameter and 80 millimeters in height, packing more active battery material. This translates to a capacity to hold more energy in the same casing. Tesla sees a 16% increase in range over the same battery pack that uses the popular 2170 cells. Based on this change in dimensions alone, Tesla did more than just rearranging and eliminating some of the components of the battery. It also changed up the materials used. Tesla has been using silicone charged with lithium, but then switched to raw silicone. There is more to this that is beyond the scope of this video, but this move has multiple positive effects. First, more silicone could be squeezed into the battery, with resulting increase in energy storing capacities. Tesla estimates this could add 20% to the range of the car. Second, it cut down the costs as silicone is cheaper to source than lithium, slicing 5% of the cost of the battery. And third, it simplifies the manufacturing process greatly, reducing the time taken by the process. Tesla did a lot of work on the cathode of the tabless battery, and the results are astounding. Batteries today use cobalt, which is the best choice from a chemical point of view. However, the process of sourcing for cobalt is the nightmare for environmentalists. They are toxic and produce a lot of wastes. The supply chain is also unstable as most of the global supply comes from a single country in Africa, the Democratic Republic of Congo. Any unrest in the country that disrupts normal mining processes could result in a downtime in Tesla's factory in faraway China. Tesla switched to nickel in making its cathodes. Apart from lowering costs as nickel supply is less volatile, the manufacturing process is less complicated, generates less wastes, and consumes less water. It also makes it easier to design a recycling process for the batteries. With the tabless design, Tesla has also improved the thermal characteristics of the battery. The tabs can be a source of resistance to the flow of electrons, resulting in heat which would have to be handled in a complicated and expensive way. This means faster charging times and more efficient discharge for the car owner. In all, Tesla has managed to cram dozens of improvements that add up to a big advantage. Battery production will never remain the same. For Tesla, this simply means cheaper and better batteries. It also means a steadier supply to support its 50% annual growth ambitions. The EV industry is very sensitive to battery costs, as it represents a third of the bill of materials. Tesla's tabless batteries could have the cost per kilowatt hour. In that case, we could see the cost of EVs dropping significantly, or the range of EVs increasing dramatically, or a combination of the two. The $25,000 Tesla car that has proven to be elusive is now looking more like a reality. Musk himself had admitted that the cost of the battery is a key factor as to when and if the cheap electric car will be seen. But with the cheaper tabless battery, it may not be long before we see an unveiling. Will Tesla share its tabless design with other EV makers? That remains to be seen. However, the tabless battery is a radical take on batteries, and it is not surprising that it is coming from Tesla, a startup that has always managed to outdo itself. Just as Musk enthused, eventually every car company will have long-range electric cars. Eventually, every company will have autonomy, but not every company will be great at manufacturing. Tesla will absolutely head and shoulders be above everyone else in manufacturing. That is our goal. Any old-timer at Tesla will have a lot to say about the period referred to as production hell. It was a time the electric vehicle startup attempted to increase its output exponentially, literally overnight with the help of a robot workforce. Even for an ambitious company like Tesla, the task was daunting. To make matters more serious, Elon Musk had basically bet his own reputation and that of the company on the success of a task that looked impossible. We all know how that went. Tesla survived and went on to even bigger things, but not with the entirety of its workforce. Today, with the benefit of hindsight, we look back at Tesla's production hell and see what it meant. The year was 2015, and Musk decided he wanted to sell a purely electric vehicle to the general public. He wouldn't entertain anything with a sub-200-mile range, and it had to be affordable. The engineers thought that they had their work cut out for them designing an electric car under such constraints, until they learned when the deadline was. Musk wanted to sell the car by mid-2017, meaning they had only 2.5 years to figure out what the car would look like. This is a process that took 5 years at more established car makers, but here was a company that had barely made it past its first decade attempting to pull it off in half the time. The car would be known as Model 3 and come to test the resolve of everybody that worked on it. Musk kept coming up with his requirements. For instance, to save on costs, Musk decided the Model 3 would have a single screen. It would also allow the front seats to be pushed closer to the front of the cabin, allowing more legroom for the backseat riders. But that move would require the designers to come up with an interior without the traditional dashboard. Musk also kicked against visible vents, and the designers scrambled to accommodate his latest wish. Things kept moving until another problem reared its head. When the Model 3 was revealed publicly in March of 2016, Tesla requested for a refundable deposit of $1,000 to place a reservation. In the weeks leading up to the unveiling, employees speculated on how much reservations the Model 3 would attract. Most staffers predicted 50,000, while a few audacious employees pegged it at 200,000. Musk knew his staff got it wrong when he arrived at a Tesla store in Century City on the day reservations opened. More than 2,000 people showed up in person at that single location to book a Model 3 that would not see production for at least another year. Musk quickly placed calls and realized it was the same story at other stores. In less than 24 hours, the Model 3 had gathered 180,000 reservations. By the end of the week, the number grew to 325,000. Tesla was swamped with reservations. Bear in mind that this was a company that had never sold up to 150,000 cars in its entire history. This was a nightmare companies wish they have, but Senior Vice President Doug Field declared to his workforce, "You are now working for a different company." Everybody quickly got to work. They had a production plan already, and there was no time to waste implementing it so as to meet the unprecedented demand. The Model 3 would be assembled at the Fremont factory starting in October of 2017. The first phase would see them producing limited units and then ramp up as they work out any minor issues with the manufacturing process until they meet the 5,000 cars a week target set by Musk. Musk played along until sometime in the summer of 2016, when a dream he had prompted him to call a meeting. The dream could change Tesla forever, although Musk's engineers would wish he stopped sleeping so he wouldn't come up with more dreams. The first bombshell was that he wanted to move production back by 4 months, which meant a start date in July of 2017. While his audience absorbed the shock and tried to formulate future apologies to spouses for unavoidable absence, Musk revealed he had been seeing the Fremont factory in his dreams, and they were full of robots doing things at high speed as they passed parts around among themselves to produce Model 3 EVs. Everything was fully automated. Musk described it using an obscure term we would advise you not to dig too deep when you Google. This thing will be an unstoppable alien dreadnought. Musk's dream called for a redesign of the manufacturing plans, which staffers already believed was something of the future. Changing everything was going to be costly in terms of money and time, two commodities Tesla had in short supply. But Musk would not be persuaded otherwise. He was dead set on his robotic factory of the future. He insisted an automated factory was going to be an advantage for Tesla in the future. As engineers started to turn in their notices because of what they felt was an impossible task, Musk remained unbothered. He even got employees that tried to push back, fired, or reassigned. Things became tense as Tesla continued to hemorrhage staff and money while building the factory of Musk's dreams. The company burned through up to $100 million per week. Fast forward to the summer of 2017, more than a year after pre-orders opened for the Model 3 and volume production had yet to start. Engineers were still battling with making Musk's robots do basic things like recognizing different colored wires and pick things reliably from the multitude of conveyor belts running around them. Customers that pre-ordered were starting to cancel But undaunted, Musk threw a handover party in which the first 30 units of Model 3 were given out mostly to employees. The batch had to be assembled by hand as Musk's robots still refused to work. Yet Musk had been tweeting the plant would be producing 20,000 cars per month before the end of the year. A distracted-looking Musk at that party made the famous proclamation that a production hell awaited Tesla. "We're going to go through 6 months of manufacturing hell. It's going to be pretty great, but it's going to be quite a challenge to build this car. Floods, fires, tornadoes, ships sink. If anything interrupts one of our supply chains, that will interrupt the production ramp. Sorry for being a little dry, but I got a lot on my mind right now." A lot was going on in his personal life during that period. He had just broken up with his celebrity girlfriend. Things did become hellish as Musk had predicted. There was the trouble of getting the factory running, and there was the trouble of working with Musk himself, who was increasingly becoming frustrated due to the stress. Perhaps as a coping mechanism, he began to behave oddly, doing things like pausing important meetings and making attendants watch clips of Monty Python. Sometimes he won't show up or cancel at the last minute. He would also attack and publicly humiliate anybody he felt had not performed. Everybody was treading on eggshells around the man that had the vision to change the world with battery-powered vehicles. By fall of 2017, Tesla had managed to get parts of the assembly line for the Model 3 working and production began to shape up, but not as fast as Musk's milestone announcements made it seem. During that quarter, only 222 units of Model 3 were made, and $1.5 billion that had been sunk into Musk's dreadnought. To be fair, Musk was dedicated to the job, passing many nights on the factory floor.
I sleep on the couch over there.
So you're just laying here on the couch?
Yeah. Last time I was here, I actually slept literally on the floor because the couch was too narrow.
By February of 2018, more top brass continued to take their leave, but as they left, Musk took on their jobs, even though he was heading other companies at the same time. Basically, people that could stand up to him had left, so he was single-handedly running the show. It had become clear at this point that Tesla had over-automated and the outcome wasn't working. Even Musk himself tweeted that the excessive automation was his personal mistake and was hurting. But his erratic acts continued, including releasing a barrage of tweets and insulting people online and during press conferences. An unnamed executive at Tesla then described the period. "For a long time, Elon would say or do something kind of wacky, and I would get up in front of my team and explain, 'This is why you shouldn't worry about it.' But eventually, it got to where I couldn't apologize anymore." At this point, about 20% of Model 3 pre-orders had been canceled. Eventually, Musk would have a tent built in the parking lot for a new assembly line as Tesla scrambled to ramp up production. The vaunted automation had been a disappointment, and Tesla had to change track. Humans were once again welcome at Tesla. The first time Tesla hit the 5,000 units per week target was July 1st, more than 2 years after unveiling the Model 3. It had cost millions of dollars and dozens of top talents. Tesla survived the production hell, to the amazement of even the staff. One of the engineers said, "For me, the fact that we were able to build at scale amid all that craziness, that's the real accomplishment. Just think about it. We designed a car that is so simple and elegant you can build it in a tent. You can build it when your CEO is melting down. You can build it when everyone is quitting and getting fired. That's a real accomplishment. That's amazing." That is not the end of Musk's personal troubles, as he would go on to call a Thai rescue expert a pedophile, smoke marijuana publicly, and announce he was taking Tesla private, landing him in hot water with the SEC. Tesla has since hit its stride with the Model 3, which has gone on to become the best-selling electric vehicle ever, and Tesla itself has become the biggest automaker in terms of market capitalization. But Tesla's production hell remains in history as a reminder that changing the world does not rest on the shoulders of robots completely. Toyota is working on next-generation solid-state batteries, but will they be a game-changer or fail to impress? To start, what exactly is a solid-state battery? Well, a solid-state battery is a rechargeable battery in which the electrolyte is in the solid state rather than the liquid or gaseous state. This means that they have a very high energy density, can be discharged and charged rapidly, and have no flammable components. A nice additional safety element. You see, generally, batteries contain two electrodes. There is an anode and a cathode, separated by an electrolyte. When charging or discharging electrons are exchanged between these two electrodes that create the current flow, aka it powers everything. As the electrolyte conducts negative ions from the cathode to the anode, electricity is produced. The two electrodes are bound together by another material called a separator. The key difference to know is that with a solid-state battery, this liquid electrolyte is replaced by a solid material. These materials have high conductivity and don't evaporate in the same way that liquid electrolytes do. This makes solid-state batteries superior to traditional ones in a number of ways that ought to be examined. There are four main stages where a solid-state battery could be better than a traditional one. They are safety, charge speed, range of travel, and energy density. As was mentioned, solid-state batteries do not have flammable electrolytes. The solid materials do not evaporate as they charge and discharge, so overheating is a minimal risk. In other words, your engine won't catch fire with a solid-state battery compared to a traditional one. Charge speed is another big deal, as traditional batteries don't exactly charge quickly. It can take hours, whereas a solid-state battery can be charged up to an 80% charge in just 15 minutes. Existing batteries only charge up to 50% in 15 minutes if you're lucky. Then we have range. Solid-state batteries can be charged and discharged many times more than traditional batteries without much of any strain. This makes them fantastic as they maintain their range over a longer number of cycles than a traditional battery. Last is the energy density. The energy density of a battery is the amount of energy it can store per unit weight. The higher the density, the more energy an electric car can store. Solid-state batteries have more energy density, so they can store more energy and last longer. Simple as that. With solid-state batteries being so great, why aren't they used more? Well, it is still a young technology in terms of being currently applicable. However, Toyota is making some big strides and hopes to become a Tesla killer with their solid-state battery. If Toyota's solid-state battery they are working on is to be a game changer, it needs to accomplish certain things. The cost is currently prohibitive to use in electric vehicles, where a car with a solid-state battery would cost far too much for almost any consumer to be interested in it. As this technology is still a lot of prototypes, and testing it hasn't been scaled up yet either. Durability is a big question too. As if there isn't much real-life testing being done with solid-state batteries, it is hard to accurately gauge just how long they will actually last in real-life applications. Plus, even if a solid-state battery is powerful, it needs a car with high-quality parts and elements to match, which again could raise prices to levels consumers will not like. Another big consumer is recharging options. Recharging stations need to be able to handle a much faster charge than traditional ion batteries. Charging stations with equipment that cannot handle the new technology may not be compatible with solid-state batteries and be useless to anyone with a car packing a solid-state battery. The driver would have a battery that can charge quickly, but not have anywhere to charge if its stations aren't upgraded for this technology, which, not to sound repetitive, but that's again a cost concern. Clearly, there are still hurdles to overcome, with the emphasis on money being an extremely major one. After all, Toyota has been working on and exploring this technology since 2012 in the hopes of making it cost-efficient and reliable. It is a technology being whipped up from scratch, and there is bound to be a lot of trial and error. There is some progress to show for it, with it quite possibly we could see solid-state batteries in the near future. But it also wouldn't be surprising if they took a handful more years to be put into development. It is still impressive to see that with the possible problems researching solid-state batteries can bring, that Toyota wants to explore it. Right now, this technology is just not applicable to the current marketplace. But if challenges could be overcome, then Toyota's solid-state battery could be amazing. Right now, it isn't too imposing, however. Due to the risk that it could pose a threat to Tesla, should Tesla start researching solid-state battery technology? Well, as of right now, Tesla is, somewhat surprisingly, not researching solid-state batteries. At least Tesla has said it isn't doing so. Perhaps as lots of their patents are around battery charging and charging infrastructure that utilizes traditional batteries, it isn't very appealing to think of going back to the drawing board and making all new tech out of the solid-state batteries. Now, clearly, Tesla is well aware of the potential of solid-state batteries and may just be waiting for the technology to mature a bit more before making a move. That is quite likely, all things considered. As of this minute, however, Tesla's official word is that solid-state batteries are not of interest. We'll see how long that actually is the case, though. To get down to brass tacks, as they say, when could we expect to see a solid-state battery in a car and on the market? As of right now, a number of experts say it could take as long as 2025 for us to see this. Or we could very well be surprised and see one from a company such as Toyota as soon as 2022, maybe 2023. Toyota is obviously keeping a lot of their work under wraps, except for the occasional promising press release. It is understandable they don't want to tell us too much, as that would doubtlessly get competitors moving into solid-state batteries in an effort to compete with Toyota. Obviously, if Toyota was to suddenly debut a car with a solid-state battery that's a good price and dependable, that would make a company like Tesla kick into gear and actually get busy at researching and making solid-state batteries to compete with them. From everything that's been said, it is clear that if a solid-state battery were to make it to the market from Toyota, then such a thing would indeed be a big game changer. As of right now, however, the technology isn't quite there yet, and companies such as Tesla don't need to be sweating in their boots anytime too soon. Solid-state batteries are definitely something to keep an eye on and consider the possibilities of, but right now a lot of the promise they hold is purely hypothetical. If Toyota does release one anytime soon, however, then Tesla maybe will need to look out. The next 5 or so years will bring many changes with electric batteries, whether they are traditional ion batteries or solid-state. It'll be exciting to see what